Another numerical technique for finding the root of an equation is the Newton-Raphson method. Suppose we're trying to locate the root alpha shown on the diagram below. Suppose A is our first approximation to this root. Consider the tangent to the curve at A. The tangent is at this point and meets the x-axis here. We're going to call this B. B is used as the next approximation. So we take the tangent at B, and then this point would be used as the next approximation. We would take the tangent here, and then here, and so on, working our way in towards alpha. Let's have a look at this in more detail. The first approximation is very often called x0. We're interested in the tangent at x0. This point here has coordinates x0, f of x0. Remember, the curve is y equals f of x. The gradient at this point is f dashed of x0. Here is the tangent, and x1, the point where this tangent meets the x-axis, is the second approximation to the root alpha. What we're going to do next is look at the equation of this tangent. We know the gradient is f dashed of x0, and that the tangent passes through the point x0, fx0. So let's look at the equation of the tangent. A tangent is a straight line, so is of the form y equals mx plus c. We know the gradient is f dashed of x0, and that the line passes through the point x0, f of x0. Substituting all of this in, and then rearranging, gives us that c is equal to fx0, take away x0 times f dashed of x0. Substituting the value of m and c back into the equation of a straight line, we get y equals x times f dashed x0 plus fx0 take away x0, f dashed of x0. x1 is where the tangent meets the x-axis, and remember, at the x-axis y is equal to 0. So we need to substitute x is equal to x1 and y equals 0 in this equation. That gives us 0 is equal to x1 times f dashed x0 plus fx0 take away x0 times f dashed x0. Rearranging, we get x1 f dashed x0 is equal to x0 f dashed x0 take away f of x0. Dividing right through by f dashed of x0 gives x1 is x0 f dashed of x0 over f dashed x0, take away fx0 over f dashed of x0. Clearly the f dashed x0's cancel, giving us x1 is equal to x0 take away f of x0 divided by f dashed of x0. So if we know the function of x and we can differentiate it, given a value for x0, we can substitute in and evaluate this expression, giving us our next estimate of the root, which is called x1. Clearly we could repeat this argument to find x2, x3, and so on, and in general xn plus 1 would be equal to xn take away f of xn over f dashed of xn. It's important not to get confused about what this means. Xn plus 1 is the next approximation for the root. Xn is the current approximation for the root. So we get to the next approximation by substituting the current approximation into this formula. You may see this formula written with n here and n minus 1 in these positions. Clearly it means exactly the same. N plus 1 is 1 after n, just in the same way as n is 1 after n minus 1. So let's consider the use of this formula. Let's use f of x is x cubed minus x plus 2. Then f dashed of x is 3x squared take away 1. There is a root of f of x equals 0 near to x equals minus 2. So we're going to take x naught equals minus 2. x1, the next approximation, is going to be minus 2 take away f of minus 2 divided by f dashed of minus 2. And this gives us minus 1.636363 and so on. x2 then is this value take away f of that value divided by f dashed of that value. And this comes to minus 1.530392. This is x2, and we're going to use that to find x3. Doing so, we get x3 is minus 1.521441, x4 is minus 1.52137971, x5 is equal to minus 1.52137907. Note how little the values are now changing. This lends itself very well to quick use on the calculator. To produce these answers quickly on calculators that have an ANS button or last answer button, input minus 2 and press equals. This makes minus 2 the last answer. Remember, minus 2 was our first approximation to the root, x naught. Type in the formula in terms of ANS. So type in ANS, take away what is essentially f of ANS, divided by what's essentially f dashed of ANS. Type it in exactly like this. Each time you press equals, you get the next approximation. So the first time you press equals you get x1, the next time you get x2, and so on. It really is worth you trying this on your calculator as soon as you finish the video, just to make sure that you can use this method. As pointed out before, notice how quickly we've converged to a value. If we're going to 4 decimal places, we can see that the last 3 have all been minus 1.5214. We should still check. We could be very confident about giving minus 1.5214 to 4 decimal places as our answer, but we should always do this check. To the left we have minus 1.52135, and to the right minus 1.52145. Anything which is in this interval would round to minus 1.5214, correct to 4 decimal places. f of x is x cubed minus x plus 2. So f of minus 1.52135 is minus 4.18 times 10 to the minus 4. The important thing is that this is negative. F of minus 1.52145 is 1.77 times 10 to the minus 4. And the important thing about this number is that it is positive. The change of sign from negative to positive shows that there is a root in this interval, and therefore the root is minus 1.5214, correct to 4 decimal places.